Okay, welcome back. This is the last video on section 6.5, or the first subsection of section 6.5, the geometry of linear transformations in R2. So we've already looked at reflections across a line, and there are three types of reflections that can be represented by an elementary matrix. The reflections across the axes, or the reflection across the line y equals x. And we saw that we could represent other reflections as a combination of those three types. And then we looked at expansions and contractions, either horizontally or vertically. There's four different types there. And those could also be represented by elementary matrices. And then we looked at a shear, a vertical shear or a horizontal shear, and those can also be represented by elementary matrices. So now, and then we looked at fixed points. We also looked at the image of the unit square under different types of transformations. So now we're just going to look at a last example. In this example, we're given a 2x2 matrix, and we're asked to write that matrix as a product of two elementary matrices, and then to give a geometric description of the linear transformation that this matrix represents. So let's look at the matrix A, and by looking at it, by the way, there's more than one way to do this. So the way I'm looking at it, I see that the second row of A, to get that second row from the identity matrix, I would multiply I would add 2 times the first row to the second row. So that's my first elementary operation. 2 times row 1 added to row 2 gives me the new row 2. Then the second operation would be to simply multiply row 1 by 2. So 2 times row 1 becomes the new row 1. So those are two separate elementary operations on the identity matrix, and they're done in that order. Be very careful about the order. If you do these particular row operations on the identity matrix, but you do them in the reverse order, your second row will turn out to be 4-1. It won't be 2-1. So make sure if you're using these two operations, you do them in this order. So now let's find the two elementary matrices that correspond with these two operations. So the first one, we take the identity matrix and we perform that first elementary row operation, adding 2 times row 1 to row 2. And we get this. We get 1, 0, 2, 1. And let's call that E1. And we can tell by looking at this is not a expansion. This is a shear. It's a vertical shear. Then the second row operation on the identity matrix, the second one was just to multiply row 1 by 2. So that gives us the matrix 2, 0, 0, 1. So we're going to call that E2. And E2 is clearly a horizontal expansion. And so what is A doing to a vector V? So the first thing it does is it vertically shears V. So we're multiplying V by E1 first. That's the first thing that happens. And then we're multiplying that vector by E2, the horizontal expansion. So then we can write A as the product E2 times E1 in that order. So notice E1 is on the right because that's the first thing that's going to happen to the vector. And then E2 is on the left because that's the last thing that's going to happen. And so A represents a vertical shear followed by a horizontal expansion. That's the geometric description of the linear transformation represented by A. And I want to emphasize again that the order of that multiplication and the order of those two transformations is important. The vertical shear is first, then the horizontal expansion. Okay, that's it for 6.5. That's all we're going to do from that section. We're not going to go into R3. And I just want to point out that all of this is sort of summarized on the first page of section 6.5, the elementary matrices for the elementary linear transformations in R2. So these are all the matrices for reflections in the two axes, then a reflection across the line y equals x. Those are elementary matrices. And then the horizontal and vertical expansions, those are also elementary matrices. And then the horizontal and vertical shears, those are elementary matrices. So as you're doing your homework from WebAssign 6.5, you might want to have this page handy. All right, and have a wonderful weekend. See you next week.